Hello, good afternoon, everyone. Welcome to our first lesson for this course, Platform Technology. For this discussion, we're going to talk about the basic or the definition of platform technology, and we'll be focusing on the first topic that is comprising what is or what are the platform technologies. So before we proceed to the presentation, please watch this video clip that is trying to explain how the operating system works.
Computers are used for so many different tasks. Playing games, watching videos, running calculations, communicating and collaborating. Computers today are a mixture of different types of hardware and software. But there is one program that brings them all together, and that's the operating system. To consider what the operating system is, let's go back in time to the invention of digital computers. They could handle around 5,000 complex calculations per second. Impressive for the time, but today's supercomputers perform nearly 34 trillion calculations per second. Programs were written on punch cards, pieces of cardboard with holes. These were fed one at a time into the Central Processing Unit, or CPU, and enabled the earliest form of computer, batch processing. In some cases, one person was in charge of making sure the cards were fed in correctly. Their job was to correct jams and schedule when the next program could be run. As computers became faster, they were able to process punch card tasks quicker than the cards could be fed in. There was another problem. Different computers' resources, that is, the components within them such as RAM and the devices attached to them, such as printers, were all different from one another. A programmer had to write very different types of programs specific to the machine it would be running on. Was it this card? Or that card? Oh no, it's all getting a bit complicated, isn't it? The solution was to write a brilliant piece of software called an operating system, or OS. The OS would take over the tasks common to many programs. Today, operating systems control the hardware of the computer. They manage and allocate resources and provide an interface for the user. Go on then, turn on that computer and we'll see what happens. An OS is one of the first programs that runs when a computer is turned on. Most programs start the same way. The computer issues lines of code as commands to prepare all the important elements, like the screen and the network. The operating system holds the collection of all the common commands and segments them, rather like putting them into a library, from which the other regular programs can borrow codes.
Is a group of technologies that are used as base upon which other application, processes, or technologies are developed. So meaning, platform is considered as the foundation of all the development of technology. So in personal computing, a platform is the basic hardware or the computer and the software or operating system in which software application can be run. So the platform or the foundation of developing a technology or any application would be the foundation. Okay, that is a platform. So when we talk about platform technology, that is the foundation of all development when it comes to computing. So it talks about hardware, which is our computer, and our software, which is the operating system, because the operating system is playing a special role in the process of computer operation. So platform standard. So platform conforms to a set of standards that enable software developers to develop software application for the platform. So it means to say that the platform conforms to the different standards, to a set of standards that is enabling developers or programmers to develop their application for a particular platform. So there are softwares developed that are compatible to any platform. When you say any platform, it could work with cross-platform. It could work with this platform for Windows or another platform, which is the Linux. That is just a basic example of a platform standard. Thus, to run a bookkeeping program on a computer, you must purchase a bookkeeping software application that was developed for the platform in which it will be used. No, that is talking about the compatibility. Compatibility, let's say for example, if you are going to install a certain program or application, platform is the most important consideration, whether that program that you are trying to install is supported with the platform with your device. Let's say for example, your computer or your cell phone itself. So multiple platforms, or these are the new standard-based interfaces and open source interfaces allow application program to run on multiple platforms. Additionally, software developers have developed software tools that allow application to run on multiple platforms. So this is what I am talking about, cross-platform, or this will work with different platforms so that all of the necessary, or that is depending on the need of the end user. Let's say for example, the availability of the device or the hardware. So if this application is only intended for this particular platform, so meaning there is a limitation when it comes to the installation or utilization of that system. So it is advantageous if the system that you are going to develop is working with multiple platforms. Cross-platform software and multi-platform software. Okay, cross-platform and multi-platform software. This has given the rise to the term cross-platform software and multi-platform software. So a classic example is represented by video games developed specifically for a certain platform, in case a console such as PlayStation or Xbox. No? So talk about cross-platform. Let's say for example Java. Java has this platform or this programming language that you're going to install in your system can work with either different operating system, since operating system is considered as a platform. So cross-platform, it will work with Linux and it will work with Windows. So meaning there is no issue on the compatibility. Or multi-platform, which means multiple platform software that this application or this software will be working with. So in here, this is a figure that talks about the technology platform. So we have here operating system, we have computing platforms, we have database platforms, storage, application, mobile, web, content management, media, and so on. So these are the different technology platforms, which is the basis of making your device functioning. Alright? So since the first topic is operating system, so we are going to talk about what is an operating system. Okay, so objective for this discussion will give a grand tour of the major operating system components. So we'll be talking about the different components of an operating system, provide coverage of basic computer system organization, and instill the importance of operating system. How important is your operating system in a particular device? So what is an operating system? So an operating system, this is not new for you because I know that you have the knowledge of what is an operating system and what are the different operating systems that you encounter, or what are the operating systems that you encounter. Okay, so a program that acts as an intermediary between a user of a computer and a computer hardware. So when we talk about operating system, it talks about intermediary. So it is trying to mediate the communication of the user to the computer hardware, because as we all know that the computer system will not work in the absence of the user and in the absence of the hardware. At the same time, the most important is the operating system. Okay, the operating system goals are the following: execute user programs and make solving user problem easier. Okay, execute user program. So the operating system is the one that is trying to facilitate the request of the end user through the use of the graphical user interface, and that will facilitate the communication to our hardware. That is to perform what are those instructions that you wanted to happen. Next is make the computer system convenient to use. Okay, when you say convenient, it would be easy to use for the user. That is why an operating system offers a very good graphical user interface for us to utilize the different application, the different process in our system. It may be using your cell phone or it may be using your computer. That is why you have different icons. Okay, make or use the computer hardware in an efficient manner. Of course, with the help of the operating system at the present, that would be efficient for us. Okay, using the hardware computer. So OS is a resource allocator. The operating system is a resource allocator. Okay, the OS is also a control program. So what we talk about resource allocator. What is resource allocation? Allocator meaning that is the one who allocates. So the OS is the one who allocates what? Okay, resource allocation simply means assigning your resources. Okay, assigning your resources, time, people, and tools across various tasks in a project to work towards deadlines. So that is the definition of resource allocation when we talk about people. But when we talk about computer or device, but when we talk about computer, operating system is serving as resource allocator. Okay, so what are the functions of an operating system that serves as resource allocator? So these are the steps. Get to know your resources. Getting to know your resources, then operating system is actually, before starting the process, it makes sure that everything, any device that are connected are functional. So that is getting to know the resources. What are the different peripherals and what are the internal connections of the computer system that are installed are in good condition. Okay, then follow the scope. The next is map out the plan. Resist the urge to over allocate. Then track and manage time. Use tools to make workload management easier. Okay, so say the operating system is actually systematic when it comes to the instruction. So the user are actually fond of clicking, giving instruction to the computer. All of the instruction are actually labeled and placed that in a particular counter. Okay, then all of the instruction will not overlap. Okay, then systematic, the process is systematic. So that is why there is a time management using the clock of the system, that every time the clock ticks, that the process will move one at a time. Okay, but only the process will be executed in just the blink of an eye, just a second. Control program. A program that enhances an operating system by creating an environment which you can run other programs. Control programs generally provide a graphical interface and enable you to run several programs at once in different windows. Okay, control program, that is the one that is trying to control the processes inside the computer. Okay, so in your computer you can run several programs at the same time. Okay, you can run several programs at the same time. That is controlled by a particular process or a function of an operating system that facilitate multiple programming that will be running in your system. So computer system structure. So computer system can be divided into 4 components. So what comprises the computer system to make it functional? One is hardware. The hardware are the tangible parts of the computer or any devices. It provides basic computing resources. Next is operating system. As we all know, that operating system has a big role in the process, which this is the one that is trying to facilitate the communication between your software applications and the hardware, right? So that is the role of an operating system, intermediary. So application programs, that is the third component. Application program defines the ways in which system resources are used to solve the computing problems of the user. So as we all know, application programs are referring to the programs that we are using as the end user. We are trying to install programs for a specific function. Let's say, for example, Microsoft Office. That is one of the example of the application program. Okay, we wanted to edit videos, so we're going to install another set of application program. We wanted to edit pictures and others. Those are application programs that are installed in our system, which is trying to solve our computing problems. Okay, and the last is the user. User is very important in a system because in the absence of the user, the computer is nothing. It will not function because user will be responsible of handling the system, turning on, checking of errors, installation, installing the applications and other. So that is the role of the user. So these are the figure, or this is the figure of the components of a computer system. So we have here the first level is the user. Then the next level that talks about the compiler, assembler, the text editor, and the database system, and so on and so forth. Alright? So it talks about the system and the application program. Okay? The system and the application program. Because as we all know that our data will not be processed without the use of the application program, and our data will not be processed in the absence of the system. Okay? In the absence of system. The next is the operating system. So an operating system falls on the third layer, which is placed in between the application program and the computer hardware. Okay, it is placed in between because when you turn on the computer, the first one that will be invoked, or the first one that will be checking everything, is the operating system. Okay, so it will check the computer hardware, whether the hardware are properly installed in the system. It will check any applications running. So that's the function of the operating system. So operating system definition has no universal accepted definition. Okay, everything a vendor ships or when you order an operating system is good approximation. So the one program running at all times on the computer is the kernel. Okay, the kernel is the one that is supervising the process. Okay, that is the one who is supervising the process on which is found at the top level of the components of an operating system. Everything else is either a system program, ships the operating system, or an application program. Okay, you know what's the difference between an application program and a system program? So a system program or a system software or software that belongs to the operating system, and the application softwares are the application that is trying to manipulate our data to solve a particular problem. So computer startup, when you are going to turn on your computer, that is what you call booting. Okay, boot, that is coming from the word boot. Booting is an action, all right, an action of turning on your computer and checking all of the functions of the hardware and your software inside. Okay, bootstrap program is loaded at power up or reboot. Okay, so bootstrap program, the bootstrap program that is actually stored in the ROM, in the read-only memory, which is permanently burned that into the chip. Okay, which when you turn on the computer, it will go directly to the bootstrap program. Okay, in the master boot record. So typically stored in the read-only memory or the EPROM, generally known as the firmware. Firmware that is actually a program that is actually stored in the hardware. So initializes all aspects of the system. It loads the operating system kernel and starts the execution. Alright, so A bootstrap program is the first code that is executed when the computer system is started. So have you noticed that when you turn on your computer, you could see text running on your monitor? That is a bootstrap program that is trying to check everything that is placed inside, whether some or most or all of the components that are installed inside are functioning. Alright, so bootstrap, in the figure here, the bootstrap read by the operating system. Okay, so the operating system in the second layer will facilitate, then after that we'll have to start the device drivers. Okay, the device driver are actually the software or the firmware that is actually paired with your hardware, that you are, when you install your hardware, device driver are also installed to your system. So that is actually in the bootstrap program belongs. Okay, so let's say for example, your mouse, your keyboard, when you are going to pull that out, then you are going to turn on your computer, the operating system through the bootstrap program will have to tell you, hey, your computer detects that your USB or your mouse or your keyboard was not successful, was not connected to your system. So that is the role of the bootstrap program. So bootstrapping process does not require any outside input to start. Okay, any software can be loaded as required by the operating system rather than loading all software automatically. So not all of the software will be loaded automatically, but it is only selected softwares which is required by the operating system. Okay, one example of that are the firmware or the drivers that are installed in the computer system. So benefit of bootstrapping. So without bootstrapping, the computer user would have to download all the software components, including the ones not frequently required. So with bootstrapping, only those software components need to be downloaded that are legitimately required, and all extraneous components are not required. So only those very important softwares installed in your computer will be loaded. That is the function of bootstrapping. So computer system organization or computer system operation. So one or more CPU device controller connects through common bus providing access to shared memory. So concurrent execution of CPU and devices completing for memory cycle. As we all know that the completion of execution of instruction, that is what you call machine cycle. Alright, so in here, these are the different devices, and different devices have also a controller. Okay, a controller which whatever processes here or whatever queries from the user, that would be controlled by the different controllers here. Okay, USB controllers. So let's say for example, for the mouse, the keyboard, the printer, there are controllers that is helping to facilitate the different action of the end user. So they are the ones trying to control. Then the graphics adapter, that is for monitor. Then these lines are actually referring to the bus. A bus is actually a lines or the passage where the data is, or the data or instruction that is passing from and to different components of the computer. And here is the memory, where the memory is actually holding the instructions, the data and instructions to be processed by the processor. So computer system operation, I/O devices and CPU can execute concurrently, or they will be executing in parallel. Okay, they can work together. They can execute the process in a parallel process. Okay, each device controller is in charge of a particular device type. So every device has its own device controller. Each device controller has a local buffer. So CPU moves data from and to main memory and from or to and from local buffers. Okay, so the I/O is from the device to local buffers to the controller. So this shows the operation of the computer system from one component to another, how they process and pass the data or instruction up to finishing the instruction process. Okay, what does interrupt mean? An interrupt is a function of an operating system that provides multi-process, multitasking. Okay, an interrupt. An interrupt is a signal that prompts the operating system to stop work on one process and start work on another process. Okay, an interrupt is serving as a traffic facilitator of the execution or the processing of information. So this interrupt is very important, because if this instruction is in the idle time, the other instruction is ready, so interrupt will have to facilitate what particular instruction to be processed first and then followed by next, and so on and so forth. That is the function of an interrupt. So an interrupt timeline, this shows the timeline of the interrupt. Okay, we have the user process executing, the input-output interrupt processing, idle time transferring. Okay, so the I/O structure starts, control, returns to user program only upon the input-output completion. Okay, so all of the input-output operations return only upon completion. Of course, when you are going to feed instruction using the input-output devices, then up to the point that you could see the output to your monitor, that is an indication that the operation is completed. So after the I/O starts, control return using the program without waiting for I/O completion. So system call, request to the operating system to allow user to wait for I/O completion. So that is what we call system call. It is requesting the operating system, allowing user to wait for the completion of input-output devices to process the instruction. Then, device status table contains entry for which I/O devices, indicating its type, address, and state. The operating system indexes into I/O devices table to determine device status and to modify table entry to include the interrupt. So this talks about the I/O structure. Storage structure. Storage, we talk about storage. We have different storage. One is memory, or the main memory, the large storage media that the CPU can access directly. So this talks about your hard disk. Okay, hard disk where all our data are actually stored into. Let's say, for example, our application programs, our operating systems, our files. That is what you call main memory, right? The secondary storage, extension of the main memory that provides large non-volatile storage capacity. Okay, extension of the main memory that provides large non-volatile storage capacity. Those are the secondary storage. Then magnetic disk. This is a rigid metal or glass platter covered with magnetic recording material. So these are what you call the storage devices that are being used by the user. So we have magnetic disk. I know that magnetic disk as of this moment is not actually very fun of use by the end user. What they're using now is the secondary storage. Let's say for example the external drive. We have the flash disk, right? The main memory is our hard disk. Then the storage hierarchy. Storage system organized in hierarchy. Storage is actually consideration are actually based on the speed, the cost, and volatility. Okay, the speed. How fast is your storage system when we talk about processing or storing your data? The cost. How much is the cost of your storage being used? Okay. Next is caching. Caching is actually an action of, okay, that is coming from the cache. C-A-C-H-E. Cache. Cache memory. All right. Caching is copying of information into faster storage system. So the main memory can be viewed as the last cache for secondary storage. So that is why our computer system, in order to address the need, or in order to have a balance in terms of processing the information. As we all know that the processor is processing million times, okay, faster than our secondary storage. That is why there is a cache memory that when the user needs this particular information to be processed from the main memory, that will be passed to the cache memory. Okay, that will be passed to the cache memory. That is in order to accommodate the need of the processor, so that the processor will not have most likely an idle time when it comes to processing the instruction. Okay, so we have the storage hierarchy. We have here the magnetic tapes. This was being used before, the optical disc, magnetic disc, electronic disc. We have here the main memory. We have the cache, then up to the registers. So the cache, the main memory, the registers are actually found already inside the system unit. Okay, so caching, important principle performed at many levels in a computer, hardware, operating system, and software. Okay, caching, information in use copied by or from slower to faster storage temporarily. So that is caching. From the slower memory will be transferred to faster storage temporarily, or faster storage. That is to one reason that it would address the need when it comes to the speed of processing by the processor. So faster storage, cache, check first to determine if information is there. So cache smaller than storage being cached. So computer system architecture. So most systems use a single general purpose processor, or the PDAs, through mainframes. We have multiprocessor system growing in use and importance. It's also known as parallel system, tightly coupled system. So this system were actually, I know that this was actually being introduced to you. So maybe there is no need to elaborate what is all about parallel system, tightly coupled system. So the advantage includes increased throughput, economy of scale, and increased reliability. So two types, we have asymmetric multiprocessing and symmetric. So what's the difference between the two? Okay, how a modem computer works. Okay, so symmetric multiprocessing architecture. So we have CPU 1, CPU 2, CPU 3. That is a figure that is showing symmetric multiprocessing. So we have different CPUs, and then we have different registers and the cache, and then we have a common memory that shares or store the information before processing and store the information after processing before that will be stored in the main memory. That is symmetric. Okay, a dual core design. So this figure talks about the processor, the CPU, which is called dual core. So when you say dual core, that is 2 CPU. When you say quad core, that is 4 CPUs. Meaning, the more CPU that is responsible for processing the data, the faster is expected the completion of instruction. Okay, so meaning it increases the speed of processing the information. So clustered system, like multiprocessor system, but multiple systems working together. Usually a clustered system sharing storage via storage area network. Okay, clustered, meaning clustered, it is a group of a system clustered together. Alright, provides a high availability system or service which survives failures. So asymmetric clustering and symmetric. So we all know what is the difference between symmetric and asymmetric. Okay, has one machine in hot standby mode. Symmetric has multiple nodes running application, monitoring each other. Okay, so that is the difference between symmetric and asymmetric. Now, some clusters are for high performance computing. Application must be written for or to use parallelization. So operating system structure talks about the multi-programming needed for the efficiency. Single user cannot keep CPU and I/O devices busy at all times. Okay, so computers today they are using multi-programming. So it organizes jobs, codes, and data. So CPU always has one to execute. So a subset of total jobs in system is kept in memory. So time sharing or multitasking is a logical extension in which CPU switches jobs so frequently that user can interact with each job while it is running. Okay, so we have response time. So the response time should be up to 1 second. So that is why there is a time manager in the operating system, or in the processor component. We have the clock there. That is to manage the time. The purpose of that is to synchronize the process and synchronize the execution from one stage to another. Okay, Each user has at least one program executing in memory. That is what you call process. Several jobs ready to run at the same time. Okay, all jobs will be placed in a counter. So that is on the CPU side to assign or to schedule according to the instruction counter, to schedule on when to process that information. So virtual memory allows execution of process not completely in memory. So when you talk about virtual memory, that is just only a, or when you relate that in a program, that is what you call an instance object. Okay, an instance object, which that object exists only out of the real object. Okay, so virtual memory is not actually existing. It is actually existing, but that is based on the physical memory, right? So this is the layout of multi-program system. So job number 1 up to job N, and then the operating system. So jobs there, the jobs here are actually labeled. That is through the use of the counter. Okay, so the counter that's responsible for counting and labeling of the instruction to be processed by the processor with the help of the operating system. Okay, we have here the process management. So process management is one part or component of an operating system. So how does this operating system manage the process? A process is a program in execution. It is a unit of work within the system. So program is a passive entity and process is an active entity. So meaning process actually is expressing action. Okay, process needs resources to accomplish its task. So how the data is being processed, but that is through the help of the CPU itself, the central processing unit, which includes the arithmetic processing or logical processing, the memory, which is storing the data while it is not yet being processed or after processing, then the I/O. These are the devices which is responsible for feeding instruction or data to the memory. And then the files. These are the actual files that you are going to open and you are going to manipulate. Okay? Then initialization of data. Process termination requires a reclaim of any reusable resources. Okay? So a single threaded process has one program counter specifying location of the next instruction to execute. So process management, this is the one who manages all of the processing of instructions into the central processing unit. So that is one of the function of the operating system. So process management activities. Operating system is responsible for the following activities in connection with process management. So the first one is creating and deleting both user and system process. So that is one of the function or the responsibility of the process management. Suspending and resuming the process. Alright? The process manager of the operating system has the capacity to suspend and resume the process depending on the situation. So providing mechanisms for process synchronization and providing mechanism for process communication. And the last is providing mechanism for deadlock handling. So all in all, those are the responsibility of the process management. Memory management. All data in memory before and after processing will be checked first by the memory manager of the operating system, that it will see to it that the data before and after processing has enough memory to accommodate that data. So all instruction and the memory in order to execute will make sure that there is enough memory to be allocated in that particular data or instruction. So memory management determines what is in the memory when optimizing CPU utilization and computer response to user. Okay, so memory management, it talks about the general overview, or the general picture of this memory management is when you are going to open a file or when you are going to save file, of course you are going to locate for a storage area. So before storing that data or a file, the operating system will have to make sure that there is enough space in that particular memory in order to accommodate the file. So try to store videos that the capacity of that video is more than the capacity of your USB stick or USB drive, or your USB stick or flash disk. Okay, so in that case, operating system will have to inform you, something is wrong. Your file will not be stored because of this blah 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 issue. So that is memory management. So the difference between the physical and virtual memory. So we're going to have a differentiation of the physical and virtual memory. So physical memory, which is the actual RAM, is a form of computer data storage that stores the current executing program. So physical memory, that is our random access memory, where all of our instruction will be passing from our main memory, that will be passed to the random access memory before it will go to the central processing unit or the CPU. So in contrast, virtual memory is a memory management technique that creates an illusion to user of larger physical memory. Thus, this is the main difference between the physical and virtual. Well, actually, literally, we could know the difference between physical and virtual. Virtual is just sort of an imagination. Okay, you cannot touch. As I've said, a virtual, or that is in programming, that is what you call an instance object. An instance object of the class, an instance object, or an instance variable. So you are trying to make an instance object of a variable in order to hold a particular data. So memory type, while physical memory is an actual memory, virtual memory is the logical memory. That is the difference between the physical and the virtual. Speed is another difference between the physical and virtual memory. Physical memory is faster than the virtual memory, of course. So technique, then the size, the CPU. So these are the illustration of differentiating the actual and the virtual memory. Storage management. OS provides uniform and logical view of information storage. So abstracts physical properties to logical storage units or the file. Each medium is controlled by device, like disk drives, tape drives. So this is quite related to what I am talking a while ago. So storage management that makes sure that your storage is existing. Let's say, for example, you wanted this file to be stored in your flash drives. Okay, so what will happen if your flash drive is not actually connected to your system? So the storage management will have to look for that. Alright, so file management system. File usually organized into directories. So access control on most system to determine who can access what OS activities includes. So creating and deleting files and directories, primitive to manipulate files and directories, mapping files onto secondary storage, and backup files onto a stable storage media. So those are the activities of OS that is included. So mass storage management, usually the disk used to store data that does not fit in main memory or data that must be kept for a long period of time. So management of mass storage. So entire speed of computer operation hinges on disk subsystem and its algorithm. Protection and security. So protection talks about any mechanism for controlling access of processes or users to resources defined by the operating system. So operating system has these features for protecting what is or what are the necessary protections that will be offered by the operating system. That is actually packaged in the operating system. So security, defense of the system against internal and external attacks. No? Security or the operating system has these features that secures everything, the files, the operating system itself, and the softwares. So operating system has this capacity to secure and protect our system. So system generally first distinguish among users to determine who can do and what can be do. Alright? So computing environments, client server computing. So client server meaning we have different nodes, we have the buses there, okay, and then we have the server. The server or the different clients or the nodes are actually connected to the server. So all of the processes will be at the server, especially the storage and the like. Okay. So computer server provides an interface to client to request services, like example for database. Okay. So file server provides interface for clients to store and retrieve files. These are two different servers that talk about computer servers. Let's say you have database here in the server, and then we have different computers here, and then the processes will be requesting data from the database as a server. Right? So same is true as the file server. Peer-to-peer computing, another model of distributed system, which is P2P, does not distinguish clients and server. So P2P meaning that is connecting one computer to another. Okay, two computers are being connected. Instead, all nodes are considered peers. So may each act as client and both, or server or both. So meaning, if you are going to connect two computers, that is what you call peer-to-peer, P2P. Okay, you can share informations using that peer-to-peer computing. Open source operating system. So open source meaning this is free, an open source, an operating system made available in open source format rather than just binary closed source. Okay, counter to the copy protection and digital rights management, DRM movement. So free softwares, these are open source, no? Okay, the GPL, the Linux, the Unix, those are examples of an operating system which are considered as an open source. So we are done with the presentation and the discussion of our first topic, which is the operating system. We have the different components and other topics which is related to the operating system. So we have here on the assessment part. So first question, why our operating system are viewed as resource allocator? Another is explain what is the Bootstrap program, where it is stored. Provide the difference between physical, virtual, and logical memory. Okay, so you are going to explain that briefly, and if possible, give an example that is to elaborate your answer. Next is we have here the identification. Anyway, this question for the assessment will be we will be providing an option for you to answer the assessment part in our LMS. Okay, so I hope that all of you have access to our learning management system, the Norsu LMS, and just open the LMS using your account and then read the instructions and take the examination for this particular topic. So I guess everything is clear. Thank you very much for watching, and by the way, this video will be uploaded to my YouTube channel. Just visit Just Sums TV, GESS space SUMS TV, then you could see this video. So thank you very much everyone. God bless us all and stay safe.